I also think it's important to point out to the people listening at home that this idea of mid-cycle changes is not as far-fetched as you might think, because we're in the middle of one of those replacement cycles, if you will. If you think back 2 years ago, as of the recording of this podcast, which would be, kind of mid 2024, the conversations all kind of stemmed around doing training for these models, ingesting as much data as possible. And today, in 2026, we're really focused on inferencing. We're focused on what you can do with the models as you built them. If you had built your network around ASICs that were optimized for training back in the day, now that everything is flipped from training LLMs to inferencing and building agentic AI solutions, you would find yourself, maybe the network is performing well, but not optimally, because we've said the ASICs are kind of single purpose. I mean, it's application specific. That's what AS and ASIC stands for. So Richard, to your point, what's the value in having a solution that is programmable and maybe can be adjusted mid-cycle to allow people to say, hey, our workload needs have changed?
Yeah, and those are questions we've actually been answering and being able to apply with the custom silicon, Tom. I'll give you an example. There was a very large hyperscaler that started their first, AI factory or cluster leveraging merchant silicon. They started noticing that these traffic patterns, as you're talking about training to inferencing, simultaneous front-end north-south traffic coupled with east-west traffic, whether you're checkpointing to different storage in the back end, or you have inference, or your AI, your data scientists are pulling something from the front end. But that traffic pattern was actually being seen, exponentially. And one of the requirements from this large hyperscaler is they wanted some flexibility. They wanted the ability to give preferential treatment to say I wanted to do packet spray on this workload, but maybe on the other workload, DLB flowlet was just fine, or I could just do regular, ECMP. But they wanted that to have, the ability within the hardware to give that best experience, best outcome, whether it's job completion time, whether it's your scientists waiting for the inference to come back. I think that was the important thing where the light bulb kind of went off. And then being able to kind of give this preferential treatment to unique workloads, all within the same silicon, with traffic going north, south, east, and west simultaneously. That was where we saw okay, this mid-cycle is for real. And we're able to leverage the P4 programmable pipeline with engineering, working very closely with that customer, being able to test it internally, standardize on that, and then make it, in our software release. I think that was one of the key things that I'm very proud of within Cisco that we're able to deliver.
I would add to that. Yes, inference is taking more attention, but I don't think the training traffic is really decreasing, because all the foundation model companies still keep putting out new models. So there's training that's going on for them. And I firmly believe more and more focus is going to be put on data and training smaller custom models. So there'll be lots of additional training workloads while inferencing keeps going up and to the right. And then the third vector is we don't know what else is coming around the corner. And if the accelerated timelines of AI development have taught us anything, it's like in 3 months, we will already have gone through the next 2 news cycles for what's new in AI. So flexibility, I think it's not just mid-cycle. It might be like, the 24-hour news cycle is forever now. Things are going to keep moving much faster, in my view.
And to something that you said in the opening, Scott, I think it's important for people to point out. Yes, we've lived through these networking cycles, if you will, where we went with hardware and then we have programmable software capabilities. We're kind of back to hardware because of the needs of the workloads. But we're in a different realm now where programmability extends the life of the hardware. So it's something that Richard just said. This idea of using P4 to program all of these pipelines is something that we really wouldn't have had in the past. And the ability to say, okay, I'm going to dedicate this box to doing this very specific thing, because by stripping out all the pieces that don't need to be there, I can make it as performant as possible. That's something that is very unique to custom silicon offerings. I don't think that you're going to be able to go out to a, off-the-shelf solution and say, okay, I want this, but I really want it in like the fire engine red with the really big tires. And most people are going to be like, well, no, you can literally just have it the way that it comes, because that's the only way we know how to build it.
I think I like the Lego blocks. I like having Lego blocks of different colors and different sizes, and I can build composable infrastructure the way I need it as my requirements evolve. And let's put it all on the table. All software runs on hardware, and what we really need to be thinking about is how the systems work together.